math, it's all about math, the wonderful world of math. Welcome to the wonderful world of math, trigonometry coming at you. We want to do factoring trig equations with factoring. So let's see, our first example has a mixture of trig functions. We've got a sine and a cosine, and this isn't one where you can add sine to both sides and then do whatever crazy things you're going to do. I can show you how that would work. You get 2 sine theta cosine theta equals sine theta, and then you might say, hey look, both sides have a sine. I'm going to divide both sides by sine. But that doesn't work, because when you do that, you ignore the possibility that sine could be 0. You don't want to divide both sides by 0, right? So we don't want to do this. We want to do something different. We want to factor. That's the name of the game. Look for a common factor here. You see, both terms have a factor of sine of theta. So when I take out that sine of theta, the first term has got left 2 and a cosine as factors, but the second term only had a sine to begin with. So when I factor out a sine, what's left? Well, sine theta divided by itself, just like anything divided by itself, you get 1. Now, this is written as a product of 2 factors. Instead of a sum or difference of terms, it's written as something times something. And anytime you have something times something equals 0, we have what we call the zero product property. This says if a product of 2 things is 0, one of the factors must have been 0 to start with, because in real numbers, you cannot multiply non-zero numbers and get 0. This is the zero product property, and it is what makes time travel possible. Just kidding, that's the flux capacitor. The zero product property is what makes factoring useful, because it says that if I have something times something equals 0, then either the first factor equals 0, or the second factor equals 0. It takes this one equation that's got too many things in it for us and turns it into 2 easy equations. So now we just have to solve sine of theta equals 0, and separately 2 cosine theta minus 1 equals 0. Sine of theta equals 0 means theta is going to be 0, or pi, or 2 pi, or really any integer multiple of pi. 2 cosine theta minus 1 equals 0 means we're going to solve for the trigonometric expression. We're going to add 1 to both sides. We're going to divide both sides by 2. And we're going to get cosine theta equals 1/2. And this happens in 2 quadrants. Cosine is positive in quadrant 1 and positive in quadrant 4. In quadrant 1, this is a nice easy angle. It's just going to be pi over 3, plus of course everything coterminal to it. And in quadrant 4, you're going to have 5 pi over 3. I don't know why I wrote a 6. I said 3, meant 3. There we go, plus everything coterminal to it. And so these are our angles. If I ask for the solutions between 0 and 2 pi, you've got 0. You've got pi. You've got pi over 3 and 5 pi over 3. 2 pi is not included because of the parenthesis here. And that's that. But if I ask for all solutions, you're going to have to say all of that for any k in the set of integers. This is the set of all solutions here. And these are the solutions between 0 and 2 pi. The next thing we want to do is the big deal. Trigonometric equations of quadratic type. What does that mean? That means that after performing a substitution, you can get your equation to look like a quadratic equation in a new variable. So you've got a times some expression u squared plus b times that expression u plus c equals 0. For example, find all solutions to 2 sine squared theta minus sine theta plus 1 equals 0. Here, if I think of u as sine of theta, then u squared would be sine squared theta. This then could say 2u squared minus 3u plus 1 equals 0 with that substitution. Ideally, we'd like to be able to move past this substitution and jump straight from here to the factoring. But for many people, it's easier to factor this when they see it written with u's. So, if that's you, go ahead and do it. Make the substitution. Figure out, how can I factor this? I know that this times this has to be 2u squared, and this is the only way 2 factors. That's 2 times 1, right? Similarly, 1 is easy to factor. 1 and 1. Or, here's the important part, -1 and -1. And you'll find that when we guess and check both of them, this one is not going to equal what we started with. This is going to say 2u squared plus 3u plus 1. It's important not just to guess, but to check. That's why it's called guess and check. Because, hey, it's entirely possible that this is not the correct factorization, and that you need the quadratic formula, right? These are the only two possible things using integers, but that doesn't mean this has to have integer solutions. And when you FOIL it, you get 2u squared minus 2u minus u plus 1, which is, combining like terms, what we started with. Fabulous. Fabulous. And like before, we're going to use the zero product property to say that if one of these factors is 0, if this product is 0, then one of these factors is 0. And we don't have to turn this back into signs just yet. We can solve all the way for u first. But once we have u on one side by itself, we do have to come back to our original expression, sine of theta equals 1/2, and sine of theta equals 1. Now these equations are things that we should be able to answer. This happens in 2 quadrants. Sine is positive in quadrants 1 and 2. Sine of theta is equal to 1/2 if theta is equal to either pi over 6 or 5 pi over 6 in quadrant 2. And sine of theta is equal to 1 only once at the quadrantal angle pi halves. So you take any of these, anything coterminal to them, and you have all solutions. So these are solutions in 0 to 2 pi. And for all solutions, like we said, we're just going to take plus 2 pi k and add it to each of these things to get everything coterminal with each of the 3 of them, where k is any integer. So let's check out the next one. This time, we've got 4 cosine to the 4th power of x, plus cosine squared of x minus 3 equals 0. And what we're going to do this substitution thing one more time. What do I have to square to get cosine to the 4th? U squared, right, is going to be based on this first term. Not u squared. So if you're having a hard time with that, remember that if this is supposed to be u squared, this is supposed to be u, some coefficient, which is just 1, times u. Well, that actually makes making u easier to pick than u squared. Don't pick based on what's here, pick based on what's here, the middle term. In which case, if you square cosine squared, you will get cosine to the 4th power. That's how exponents work, the power rule of exponents. We multiply the exponents when we have an exponential expression raised to a power. So this is u squared, 4u squared. That's good. 4u squared plus u minus 3. Remember that cosine squared by itself was u, right? So this becomes u, and this is going to be what we factor. How do we multiply two things together to get 4? Now there's a couple of ways, right? You could say 2 and 2, or 4 and 1. 2 and 2 is going to be pretty easy. And how do we factor -3? So I want you to try to find all the different ways you could factor this. Two things whose product is 4 in the front, and two things whose product is -3 in the back. You ready? Did you find all of them? If not, pause it, and seriously, I'll wait here. Okay, 3, 2, 1. I assumed that you have paused it and worked on it by this point. Did you find at least 3? Good, because there's more than that. These are all the combinations, and if you haven't found all of these, I want you to check all of these. FOIL each of these and see which one is going to be the magic ticket. So 3, 2, 1. Which one of these is the magic ticket? It is the third one on my sheet. I don't know which one it is on yours. Hopefully you got the right one. This is what we want. We can get rid of everything else. And now we use the zero product property to say that if this product is 0, then one of the factors must be 0. And we solve each mini equation for u. We'll get u equals 3/4 or u equals -1. Now on the left side, we turn this back into sines, or cosines, sorry. Cosine of x equals 3/4 or cosine of x equals -1. Is that right? No. No, it's not right. Look back up here. We have somewhere on our paper where it says what u was. U is cosine squared. This isn't cosine of x, it's cosine squared of x. And similarly here. This is a huge deal because cosine squared of x equals a negative number has no solutions. Well, no real solutions, right? You can't have a square equal a negative number if you're using real numbers. But this guy over here has plenty. Don't worry about that. Cosine squared of x means that if I want to get cosine x, I need to take the square root of both sides. And when I take the square root of both sides, always plus or minus. And the way you take the square root of a fraction is to take the square root of the top and the bottom, if that helps you. And it does, because radical 3/2 is something we're used to. So now we're faced with this was a dead end. We can forget about it. But this gives me cosine is positive or negative. As long as you figure out what reference angle is, you've got 4 quadrants to work in. In the first quadrant, this is going to be pi/6. In the second quadrant, where you have a negative radical 3/2, this is going to be 5 pi/6. And back in the third quadrant, where you're once again negative, 7 pi/6. And in the fourth quadrant, you've got x equals 11 pi/6. There we go. You'll notice that these guys are pi units apart, and these guys are pi units apart. So if we ask for all solutions, we don't actually need to say pi/6 plus 2 pi k and 7 pi/6 plus 2 pi k. We get pi/6 plus 1 pi k, and that's going to alternate between those two lists, but it will get all of the same stuff. And similarly for these guys. We don't need 5 pi/6 plus 2 pi k and 11 pi/6 plus 2 pi k. Adding 1 pi k will bounce from this list to this list and back and forth. And you'll have all of those things. For our next one, we're going to do tangent. We want to factor this with tangent. Now let's see if we can skip the u substitution. If you want to do it, I would recommend pausing it and working through it. We're going to try to do it directly. What times what equals tangent squared? Well, the easiest way to factor that is to say tangent times tangent. And then we can kind of proceed with the numbers part normally. Two things, a number here and a number here, whose product is 6 and whose sum is 7. Product is 6, sum is 7, how about 6 and 1? That sounds good. Now if we FOIL it, tangent times 1 and 6 times tangent add up to the like terms, 7 tangent x. 6 times 1, last times last. And tangent times tangent was tangent squared. That part was really not in question after the beginning. Now what do we do? Now we use the zero product property to say that if the product is 0, then one of the factors must be 0. So either the first factor or the second factor has to be 0. And then you set each of these equal to 0 and you solve for the trig expression. Tangent x equals -1 or tangent x equals -6. Let's start with this one. Where is tangent of x equal to -1? Tangent is negative in 2 quadrants. What are they? I hope you said 2 and 4, because that's where it's happening. -1 is an output we should expect to get from tangent. The angle, going to do this, between 0 and 2 pi, is, first of all, 3 pi over 4. You would also see 7 pi over 4, but then you would also see 11 pi over 4 and 15 pi over 4, etc. This, like tangent, is based on the period of tangent, pi, not 2 pi, like sine and cosine. So 3 pi over 4 plus pi k. And that wraps that up. But over here, -6 is not a typical output. We don't see that a lot. In order to get an answer for this one, we're going to have to use inverse functions. And the best way to do this is usually, especially if I ask for something between 0 and 2 pi to start with, to talk about reference angles. Reference angles means tangent of something else. Let's call it theta is equal to a positive 6. Why positive? Well, because reference angle means positive and acute, right? So arctan of -6 is going to give you an angle between negative pi halves and 0, which is here, right? A negative degree angle, so that's clockwise. Counterclockwise for the always positive reference angle, which we're calling theta here. Now when I put that in standard position, that's going to make it in the first quadrant. This is also theta, but in standard position. If we know that this is in standard position, means it's in the first quadrant, that means that its tangent is positive. Hence, tangent of the reference angle is positive 6. So theta is the inverse tangent of positive 6. That's the reference angle. Now how do I get somebody in the fourth quadrant? Or, for tangent, I could also ask about the second quadrant, as we just saw. Since the period of tangent is just pi, I could pick either one of these. We're going to go ahead and do the second quadrant, just for funsies. So here, we're going to have this. Here's going to be our x, and this is our reference angle, theta. You'll notice that this angle, x, plus this angle, theta, add up to pi. This gives us our formula for the reference angle in quadrant 2. So x is going to be pi minus tangent inverse of 6. And then to get all angles that are solutions with this reference angle, we'll say plus pi k. Again, because the period of tangent is just 1 pi, you say plus pi k. So here you have the two solutions between 0 and 2 pi, and here we have all solutions. For our last example, I want to remind you of something else. Now this isn't quadratic. You can see the biggest power of sine is the third power, and the next power is squared. So this is definitely not quadratic. So the reminder here is, before you try anything else, for factoring, you want to look for the greatest common factor between terms. And they all do have a common factor. What is it? The greatest common factor is sine of x. So you factor that out, and this remainder over here, this is quadratic, or of quadratic form anyway. We don't want to forget about this. We want to keep factoring the rest of this stuff and leave that sine of x on the outside. So hopefully this stuff is easy to factor. Sine of x and sine of x. And you're going to have plus 6 and minus 1. You can check it, but that's what you're going to have. And then we set each factor, each of the three of them, equal to 0, using still the zero product property. The zero product property doesn't really care how many factors you have. You just set every one of them equal to 0. So we've got this. And sine of x equals 0 means x is going to be pi times some integer k. Sine x equals -6. Hang on a minute. Ein Minuten bitte. What is the range of sine? What are the possible y values again? -1 to 1. This is not going to happen. No solutions. And sine of x equals 1 is going to be pi halves plus 2 pi k. And that's that. Hooray! And there was much rejoicing. Yay! So we're done. The constellation of the day is Caelum, which is the engraver's chisel, unrelated to the Latin word for Calum, heavens, sky, cool, right? Totally different word. And this has been a Badger Bear production.